hydrogen atoms have just one proton, but not all hydrogen atoms are identical. That's because some have more neutrons than others. Most hydrogen atoms are like hydrogen 1,1. It has one proton and one electron, but no neutrons. But a few are like hydrogen 1,2. It has one neutron. It is called deuterium. And some are like hydrogen 1,3 with two neutrons. It is called tritium. The three atoms are called isotopes of hydrogen. Isotopes are atoms of the same element with different numbers of neutrons. Most elements have isotopes. For example, calcium has 6, magnesium 3, silver 2, and carbon 3. All three occur naturally. For example, in the carbon dioxide in air. But only about 1% of carbon atoms are carbon-13. Only a very tiny percent are carbon-14. Carbon-14 is radioactive. That means the atom is unstable. Sooner or later it breaks down or decays, giving out radiation. Many elements have radioactive isotopes. Radioactive isotopes, or radioisotopes, decay randomly. We can't say whether a given of carbon-14 will decay in the next few seconds or in 1,000 years. But we do know how long it takes for half the radioisotopes in a sample to decay. This is called the half-life. The half-life for carbon-14 is 5730 years. So if you have 100 carbon-14 atoms, 50 of them will have decayed 5730 years from now. This helps us work out the age of ancient fragments of wood, bones, and cloth. All contain some carbon-14, so we can date them by measuring the very faint radiation they give out. This is called carbon dating. As you saw, some atoms of an element are heavier than others. The relative atomic mass of an element is the average mass of its atoms. It is written in short form as R. For example, bromine has 2 natural isotopes. Half of the bromine atoms in the world have 44 neutrons and a mass number of 79. The other half have 46 neutrons and a mass number of 81. So it is easy to see that the average mass number for bromine is 80. It is unusual to have equal percentages of isotopes like this. You can use this formula to work out relative atomic mass. Relative atomic mass of an element, percent, mass number of the first isotope, plus percent, mass number of the second isotope, and so on, for all its natural isotopes. For example, chlorine also has 2 natural isotopes, chlorine-35, 75%, and chlorine-37, 25%. Using formula above, the relative atomic mass of chlorine is 35.5.